Hello everyone, welcome to Simplilearn's YouTube channel. Today we will be learning the Java programming. In this particular Java programming tutorial, we will be having a complete brief overview of all the major fundamentals in Java programming language. If you are new to our YouTube channel, then consider getting subscribed to our YouTube channel as we have daily updates on multiple technologies. And also hit that bell icon so that you can never miss an update from us. So this particular Java programming tutorial is divided into two parts, the fundamentals and the object-oriented programming concepts. So without further ado, let's begin with the fundamentals. So the first one in the fundamentals is the data types. So every programming language has a data type. So what exactly is a data type? So whatever the input you provide in your program is a data type. For example, if you provide numbers, so in that particular numbers, we have a different variety of numbers. If you are giving just 1, 2, 3, so on without a decimal number, then that particular type of input, which is a number, will be considered as integer type. If you provide the same number with a decimal point, then that will be considered as float. And if you have the range greater than float, it will be considered as double, and so on. So this is how we have multiple data types in every programming language. So the most frequently used data types in Java programming languages are as follows. At first we have the byte, followed by that we have short, int, long, next float, then double, boolean, and finally char. Apart from this, we also have few other data types, but these are the most frequently used ones for all the basic programmings. So this is made for beginners basically. So you can take a quick screenshot of this particular slide so that you can have a quick overview or reference to all the data types in Java programming language. So I hope you have taken a screenshot of this. Now let's begin with the next concept. So in the next concept, we have the keywords and variables. So all the programming languages have variables and keywords. So variables are used to store the values. So for example, consider that you wanted to run some arithmetic operation on two different values, that is 5 and 10. So in order to do so, you might want to create a variable which stores them. For example, you wanted to store the value of 10 in a certain variable A and the 5 in a certain variable B. So if you apply the arithmetic operation, that is A is equals to A plus B, then the value of A, which was previously 10, will be updated to 15. So here you can see the value is varying, and also it is storing the result. So this is why the variables are used in a program in order to store a value, and this particular term variable is used because the value can change at any instance of time once after a certain arithmetic or a logical operation is performed on that particular variable. So similarly, we have keywords. Unlike variables, keywords have a special meaning. No matter whatever you try, you cannot change the meaning of that keyword. For example, consider main. So you cannot use the term main for normal things because the part or the term main is dedicated for a different purpose. So whenever you try to execute your Java program, the control flow will start executing the program right when it reads the term main. So it has a special meaning. Similarly, you have other keywords such as int, so that is dedicated for integer type of values, and float for float type of values, that is a decimal values, and byte for byte, char for character type data, string for string. So every keyword or every term with special meaning which is predefined and cannot be changed is called as a keyword. Now let's see the most frequently used keywords in Java programming language. So similar to the previous one, we have a table here. So in this particular table, we have the most frequently used keywords in Java. So you can see we have boolean, final, byte, native, and we have void, switch. So switch is a conditional statement. So we have if it is also a conditional statement. We will go through these conditional statements as we proceed in our tutorial. And you can also see the protected. So this term, which is protected public, so this is basically the access modifier. Even this particular keyword have special meaning. This public, this protected keywords provide the information to the compiler or the interpreter about the accessibility of that particular data member or data manipulating method. So if it is protected from your accessibility or is it available for you, it's provided by these keywords. So we will deal with access modifiers in the upcoming parts, don't worry about that. And as you can see, we have implements, extends. So extends, this term comes in inheritance. So inheritance is one of the crucial concepts of object-oriented programming. You can also see abstraction. So this we will be dealing in the next upcoming part, where we will understand the object-oriented programming concepts. Next we have interface, return, and so on. You can also see some keywords like throw. So throw will come in exception handling. So we will also learn about exception handling in the upcoming part. So these are the most frequently used keywords in Java. So now we will move ahead into our next concept. So the next concept is the operators in Java. So to understand operators, let's go through a table. So on my screen you can see a table which has some arithmetic operators which are most commonly used. That is the plus for addition, minus for subtraction. Similarly, we have star, forward slash, double plus, double minus. So double plus and double minus, say they are increment and decrement operators respectively. As you can see, we have a plus plus here, which means the post increment. So the first value will be read, after that the value will be updated. Next we have the pre-increment, the value will be incremented first, then the updated value will be stored. So that's how the increment and decrement operators work. So we have the modulus over here. So to understand the operators that we use in Java in a much better way, let's try to execute a sample program. So on my screen you can see a program which is based on operators. So we are currently on the Eclipse IDE. Don't worry about the IDEs in Java, etc., etc. So I will drop a link in the description box below, which will explain you in a very detailed way about how to install Java into your local system and how to install Eclipse IDE in your local system, and also how to create your first project, how to create your package, how to create a new class, how to write your program and how to run that, how to see the output, and a complete overview of the Eclipse IDE, how that works. So everything will be linked in the description box below. You don't have to worry about that. So right now, to save time, I have created the text document which has all the programs that we will be executing today. So I will also drop a link for that particular file so that you can have complete access to that file, so that you can run the programs in your personal PCs or laptops and also understand the programs in a much better way. So now let's begin with the program. So this particular program is basically designed for arithmetic operations. So you can see we have the operators, that is the addition, subtraction, multiplication, division, modulus, and exit. So basically we will be taking input from you. So the input will be taken by the user. That is, we are using scanner class here. So scanner class takes the input from user, and that particular input will be compared here. So we are using the switch case here. So if you provide the option as 1, then addition operation will be run. Similarly, second for subtraction, third for multiplication, fourth for division, fifth for modulus, and sixth to exit. So this is how the loop or the program works for arithmetic operations. Now let's quickly run this program and see the output. So you can see the program got successfully executed, and we have the console asking for the first input. Let's provide some random number. Now let's provide the second number. So there you go, we have our options over here. Now let's choose division operation. For that you need to provide the number 4. So there you go, we have the result over here, which is 4. Now the loop has started once again. Now it's in the starting stage again. It's asking for numbers. Now let's provide a 25 and 5. Now let's choose some operation, that is addition. So for that you need to provide 1. So we have the result again, that is 30. Now let's again choose some number, 10, 5. So basically that's how the program works. So we have the brief idea how the program is running now. So now let's quickly continue with our next topic. Now to terminate this loop, you can provide the option number 6. So we have terminated it. So I hope you understood how the program flow is running. So if you did not understand, don't worry, I have linked the document in the description box below. You can take the access of that particular document and you can check the program and run in your local system, and also you can make some modifications to it. As you can see, we don't have a default case over here. I've just placed the case 1 to 6, and I'm saying the default because you can see that the options are from 1 to 6. What if the user provides the number as 7? Right? So the program might crash over here. So for that purpose, you can write in another case that would be the default case. So the default case will check if the number is anything above or out of the range of 1 to 6, then it should be providing you with an output saying a wrong input has been given, or check your input, or something similar. So that's how you can make some modifications to it. You're free to modify the code as well. Don't worry about that. So now let's quickly begin with our next concept. So in the next concept, we have the conditional statements. So what are the conditional statements or the control statements? So basically these are these are conditions. So what happens is, just imagine that you wanted to do something, or if you wanted to drive a vehicle, or if you wanted to drive a bike. So the condition you will apply on your mind is, if I know driving, then I will do it. If not, I'll not do it. So that's what you do, right? So basically you apply a condition on your mind and you do it if it is capable of doing, or if you are capable of doing it. So in the same way, the conditional statements play a major role in computer logic. So before writing a code, or before you start your program, you provide the condition. Perform this particular operation if the provided condition is satisfied. So similarly, you have these three conditional statements in Java, which are if else, and nested if. So we use these conditional statements in Java to implement our logic. So we will understand the conditional statements, particularly if else, and nested if, in a much more detailed way by practically running some programs based on these three types of conditional statements. So now you can see that we are back on the Eclipse right now. So this particular code segment is based on the if condition. I hope the program is visible. Let's try to increase the font size. So I think it's better now. So basically we have an input. So we have the integer type of input, that is num, and we have the number as -100. So it is a negative number. And after that we have the if condition. So this is where the conditional statement is provided. So the condition is, if the number is greater than 0, if the provided number is greater than 0, then the control should enter the loop, which is this particular segment, and execute the statements present inside that particular loop. So here we have one single statement, that is a print statement, that says the number is positive. In case the condition fails, imagine that the condition fails, then what happens is that instead of entering this particular code segment, the control will skip and execute the next statement, that is another printf statement which we have over here, which says the if condition is terminated, control is outside the condition block. Now since we have provided a negative number, the second option should go ahead. Now let's try to run this and see the output. So there you go. As expected, the program got executed and we have only one statement, that is if condition is terminated, control is outside the block. Now let's try it otherwise. Let's just eliminate the negative number and now check it again. There you go. Now you can see the program got executed and now we have two print statements. You can see that the condition here was true, so the control entered into the statement or the code block, and this particular statement got executed successfully. Once the statements are executed and there is nothing else to do, then the control will automatically exit this particular statement and it will enter into the next statement, which is another printf statement, and we have the same output over there. So this is how the single if statement works. So you can also modify this with an else. So that's the next program that we are going to see. We are going to execute some similar kind of example for our next kind of conditional statement, that is if else. So here only we had one if condition. So in case if this particular condition fails, then we will be having another condition over here, which will be the else block. So as you can see, we have another program. So this particular program is based on if-else condition. So here you can see that we have our first if condition, which states number should be greater than or equals to 0. If this particular condition is true, then this statement should be executed, which says the number is positive. Else, if this condition fails, then what you must do? The control should avoid entering this particular segment, and it should directly hit the next segment where we have the else block, which has another statement which says the number is negative. So this is how the program works. So here we will be doing a little modification over there. Instead of taking an input which is previously defined as it was in the previous example where we had given -100 previously, we are going to do it a little differently. This time we'll be taking or reading the input directly from the user. So for that we are going to use this scanner class. So this is the particular library that we will be using. So we have imported java.util.scanner. So this particular code segment will ask you for the input, and you will press some random number and it will read it as its input. Now let's try to quickly run this program and see the output. There you go. The program got successfully executed, and now it is asking for an input from the user. Now let's try to provide a negative number. So there you go, the program got successfully executed, and you can see that since we had given a negative number, the control did not enter this particular code segment at all. It directly avoided to enter this code segment and entered into the else block and executed the statements present in that particular else block, which was a simple print statement that had the statement which read as the number is negative. Now let's try to execute the same program again and see what would be the output. So there you go. Now it's asking for the input again. Now this time let's provide a positive number. So there you go. Since we provided the number as a positive number, this condition was true and this particular statement got executed. Since one of the statements executed, there was no need for the else block to be executed again. So you can see this particular code segment runs in this way. So once the condition is checked, so if the condition is true, then the true statement will be executed. In case if the condition's result is false, then the false statements will be executed. So you will be provided with two options. So one option for true validity and another option for false validity. So this is how the if-else block works. I hope you understood this. Now with this, let's continue with the next type of conditional statement, that is the else if ladder. So on my screen you can see there is a change of program. We have stepped into the next type of conditional statement, that is the else if ladder. So basically everything will be same. We will be provided with only one condition. So we will be checking the validity of that particular condition. So if the provided condition is true, then the first one will be executed. If it is not, then the second one will be executed. If the condition fails for the first two, the third one will be executed. If the first three fail, then the fourth. And if all the four fails, then we will have one last else which will print the last segment or statement. So this is how the else if ladder works. So basically it's completely similar to if else, but the only difference is instead of one else block, we have multiple else blocks. That's the only difference. Now let's quickly execute this program and see the output. So basically we are going to take an input from the user. So we will be entering 1 for noodles, 2 for milkshake, 3 for fruits, 4 for coffee. So something like that. And if we provide anything else than 1, 2, 3, 4, then we will be having an else statement which says it's an invalid input. So the flow of this particular else if statement is similar to the switch statement. Having said that, we will also discuss something about switch statement as well. Basically we'll try to execute a program based on switch statement, and we will also understand the control flow of that. Don't worry about it. Now let's quickly execute this particular program first. So there you go, the program got successfully executed. Now it's asking for an input. Let's select noodles. That's how it works. We have the output noodles. So the choice is equals to 1. So the first one was true. So it executed the first code segment and everything else got suspended because this was not necessary to be executed because the condition was true over here, and according to that only this particular statement was supposed to be executed. So that's how it works. Now let's switch into the next conditional statement, which is the switch. So you can see that we have a program on my screen which is based on switch case. So you can see that there is some similarity between this particular program and the first program we dealt with, that is based on operators. So we also have the default code segment over here. So this was what I was talking about. You can add a default code segment in that particular program, which is the operators program, and do some modifications. So this is what the suggestion I gave over there. Now basically what happens in this particular code segment is, so we have Monday as the day 1 of a week, Tuesday as the day 2 of the week, and so on. So to select one particular day of a week, you need to provide an input. So it's based on 1, 2, 3, 4 and so on to 7. And if you provide anything else than 1 to 7, you will be provided with a message which says invalid input. So now let's try to run this program and see the output. So there you go, the program got successfully executed. Now let's select the weekend day. So which would be something between 6 and 7. So 6 is Saturday and 7 is Sunday. Let's go with 7. So there you go, Sunday. Now let's try to execute this program once again and give a wrong input and see if it works or not. Let's provide 8. There you go. The program identified it as a wrong input, so it gave us a message invalid input. So that's the use of default code segment in switch case. So you can implement this in that operators program and check out how it works. Can be considered as a homework though, not a problem. Now this is how the switch case works. So with this, let's move ahead into the next concept in our Java tutorial for today. So the next segment is about the loops. So what are loops? So conditional statements are some statements which get executed based on a condition if the condition is true. If not, then that particular condition will not be executed. Loops are a little different from conditional statements. How? So basically you will be provided with one single statement and you wanted to execute that one single statement for a particular number of times. So in that condition, instead of writing the same code segment for several number of times, you can just use a loop. For example, consider that you wanted to print numbers from 1 to 10. So the brute force method, or the simple or the first method that fires to your mind is write that print statement for 10 times. That is print 1, print 2, print 3 and so on to print 10. But what if you had to print 100 numbers? Okay, doable. You can write the same print statement for 100 times. But what if you had to print 1000 numbers? Imagine 1 billion. Can you do 1 billion print statements? No, right? So in that scenario, you can use loops. So you can just write one condition. Repeat this particular print statement for 1 billion times. Then the interpreter or the compiler will take care of that. So that's the reason why we use loops in Java. So basically we have 3 loops in every programming language. That is the for loop, while loop and do while loop. So a loop statement in Java execute a set of statements until a specific condition is satisfied. So here the 1 billion example. So here you will start from the 0th count. So that will be the counter variable which counts the number of repetitions, and followed by the counter variable you will be having the condition. So you will be having the counter variable I is less than or equal to the number 1 billion. So until that you have to print this particular statement. And followed by that you will be having the increment or decrement operator. In this case you need to use the increment operator. For the first time, once the print is done, you will increment the value to 2 and the loop will be iterated once again. So this will continue. The loop will iterate itself until 1, 2, 3, 4 so on, and until it reaches 1 billionth number. So that's when the condition fails. I is greater than or equal to 1 billion. So that's when the condition fails. The condition was to be I should be less than or equal to 1 billionth. So when the number increments above 1 billion, then the condition fails. So the condition was the number should be less than or equal to billion, but the number has exceeded the billion. So that's when the loop terminates and executes the next statement after the loop. So I think this was a little clear about the loop workflow. Now to understand the loops in a much more better way, let's execute an example for each one of these types of loops. So we have for loop, while loop, and do while loop. Let's execute the programs for all of these three. So you can see that we have a program on my screen. So this particular program is based on for loop. So you can see that the code part highlighted on my editor is the for loop. So you can see int I is equals to 1. So this is the counter variable. So I is the counter variable which stores a number from where the count should begin. So sometimes you can choose 0, sometimes 1, or the number of your choice. So here I've chosen the number 1. So after the initialization part, we have the condition part. So remember the 1 billionth example we discussed before? So here we have I should be less than or equal to 10. So this particular loop segment will run until the condition, that is I value should be less than or equal to 10, is satisfied. Once it turns false, the control will exit the for loop. So that's how it's designed to work with. Now followed by the condition, we have the pre-increment operator. Once the condition is checked, the control will jump to the next statement, that is the pre-increment operator, and it increments the value of 1 to 2. So this is how the loop works. Now let's try to execute this program and see the output. There you go. The program got successfully executed and the output has been printed. So basically, what was this statement to be executed? It was a printf statement looped plus. Here the plus symbol works as a concatenation operator. Here too. Now in between the printf statements, we have the value of I. So in the first place, I was equals to 1. Once the pre-increment was taken place, the value of I will be increased to 2. So there you go, you can see the number 2 over there. Now in the second iteration, we print the value looped 2 times. Similarly, in the third iteration, looped 3 times. So that's how it works until the last iteration, that is looped 10 times. So once the condition is checked here, the control will enter into the next part where the pre-increment takes place. So the pre-increment increments the value of 10 to 11. Now the control will come back to the initialization part. Here we have the new value for I, that is 11. Now 11 will be checked against the condition. Is 11 less than or equal to 10? No, right? So the condition here fails. Now the loop is terminated. The control will exit the loop. So this is how the for loop works. Now let us also consider another example for for loop for a better understanding. So in this particular program, we are going to print the sum of n numbers. So in that particular n numbers, we will be having even numbers and odd numbers. For example, consider that you have provided the number as 5. So the numbers in between 0 to 5 or 1 to 5 are 1, 2, 3, 4 and 5. So the 4 is even number, and apart from 4, everything else are odd numbers. So odd numbers are the numbers which are divisible by 1 or itself. So now the sum of odd numbers is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 5 is 11. So that's how you print the sum of odd numbers, and the sum of even numbers, that is only 4. So that's how the loop works here. You have the condition, if else condition, and out of that if else condition you have the for loop. So this particular loop should be running until a given number that will be given by you. So that's how the program works. Now let's quickly execute this program and see the output. So there you go, the program got successfully executed and now it's asking for an input. Let's check out 5 itself. Now you can see we have another program on my screen which is basically based on the same for loop. So here we have the for loop. We will be providing an input which is num, and inside that we have another condition, that is the if else loop. So basically if loop is dedicated to find out the even numbers and else loop is dedicated to find out the odd numbers. Now the whole motto of this particular program is to find the sum of even numbers and the sum of odd numbers between 0 to the input number which you provide. For example, consider if you provide the number 5 as the input, then in between 0 to 5 we have odd numbers and even numbers. So the even numbers are 2 and 4 and the odd numbers are 1, 3 and 5. So basically what happens here is we are going to add up the numbers. So the sum of even numbers, that is 2 and 4 is 6, and sum of odd numbers, that is 5 plus 3 is 8, 8 plus 1 is 9. So that's how it should work. Now let's quickly try to execute this program and see the output. So you can see the program got successfully executed and now it's asking for an input. Now let's enter 5 itself and see the output. So there you go. The sum of even numbers up to 5 is 6 and the sum of odd numbers up to 5 is 9. So this is how the program works. Now apart from for loop, we also have another way to declare the same for loop. So that particular type of for loop is called as the enhanced for loop, or in some cases it's also called as advanced for loop. Let's see how the for loop is declared in a different way. So instead of using the typical for loop, which has the initialization state, then the condition, then the pre-increment or post-increment or decrement kind of operations, we simply have declared the for, and inside that we have int arr, which is the name of the variable of array type, and inside that we have the array. So our array consists of 10 numbers followed from 1 to 10, and now this particular loop will execute for 10 times or until all the values in the array are printed. So now let's try to print this. So there you go, the program got successfully executed and we have all our values from 1 to 10, which were the input or the saved part of the array. Now with this, let's continue with the next kind of loop, that happens to be the while loop. So you can see an example based on while loop on my screen. So basically everything is same. There is no much of a difference between for loop and while loop, but the only difference is the keyword. Instead of for, we have a while over here. So we have the while condition over here, which says I should be less than or equal to num divided by 2. And if this condition is true, then the control should enter into the conditional statement if num modulus I is equals to 0, flag is equals to true, and break. So basically the whole motto of this program is to find out if the given particular number is a prime number or not. Now let's quickly try to run this program and see the output. Now you can see the program got successfully executed. Let us try to provide a prime number and see if the program could identify it correctly as a prime number or not. There you go. The prime number we provided was 5 and the program successfully identified it as a prime number. So that's how the while loop works. Now let's execute another program based on while loop, but this time we will place the condition at the end of the loop. So yeah, you guessed it right, this is do while loop. The only difference between while loop and do while loop is that before the condition is checked in while loop, no statement is executed. But it's completely opposite when it comes to do while loop. First, the program or the code segment will be completely executed. After that, the condition will be checked. Surprising, right? Let's check out the practical part. Yeah, we have our program on my screen right now. So in the previous program, we had the condition somewhere over here. That's the while condition. But here we have the do statement here. So what we are going to do is we are conveying the compiler or the interpreter to execute this particular statement first without checking the while condition. So this is the only difference between while loop and do while loop. So we have run the program successfully and it got executed, and we were supposed to actually print the values of I from 1 to 20, and they have printed over here. That's how it works. Simple, right? Now with this, let's continue with our next topic. So basically the next topic is the next segment in our tutorial, that happens to be the object-oriented programming in Java. So before we begin with the object-oriented programming concepts, the first major things that we need to learn are the classes and objects. So the whole object-oriented programming concept revolves around these two basic fundamentals, which are the classes and objects. So what exactly are the classes and objects? Let's learn them through a definition. So classes can be defined as a template or a blueprint that describes the behavior or state that the object of its type supports. And in Java, the objects have states and behaviors. An object is an instance of the class. Okay, it sounds a little complicated. Let me break this down through using some simple concepts. So imagine that you wanted to build a car. Let's consider the Tesla car. So if you wanted to build some n number of Tesla cars, then before that, you need a blueprint of that particular car. So here the blueprint of the Tesla car can be considered as the class. So using the same blueprint, you can create any number of cars which are called as instances in the language or in the terms of Java. So the cars or the instances that you create using the blueprint, that is using the class, is known as an object. So this is how it works. So basically the blueprint of what you use to construct is called as the class. So we'll also talk about the constructors in a while. The object or the thing which got constructed using the blueprint is called as the object. So I hope this was a little clear. So now we will learn the constructors in Java. So first we will begin with the definition of a constructor. So a constructor is basically a built-in method that is used to initialize objects. The constructor is called when the object of a class is created. So as we discussed before, so whenever you wanted to create a new object, you use the blueprint, that is the class. So whenever you wanted to initiate the process of creating an object, then the constructor is called by the interpreter, then it starts the process of building the objects. So this is the basic technicality how the background process works using the constructor. So typically there are two types of constructors in Java. One is the parameterized constructor and the other one is the default constructor. Now next in the docket is the first one out of the object-oriented programming concepts, that is the abstraction. So we will understand the definition of abstraction first. So abstract class is a template of methods and variables used in a program. Abstract class cannot be instantiated directly. So we read that the objects are created by instantiating the class, but here we have the abstract class. So the term abstract basically explains it all. So abstract is like you are keeping something from the user. So when you create a program or when you create a software, there are a hell number of complexities in the program. So imagine yourself being the developer and some client comes to you for some kind of software. So what is the client concerned about is the final product. He is not concerned about your ways of implementing logic or your coding process or whatever it is. So basically abstraction is providing the user with the information or the details he requires or he feels necessary, and you try to avoid the user from getting into the complex coding part. You're avoiding him from reaching to the complex coding part. So basically that's what the abstract class means, providing the end user with the necessary information by hiding the complex details of coding. Now to understand abstract classes in a much better way, let's go through a sample program. So on my screen you can see an example for abstract class. So how can you identify a class as abstract? Simple. You can see the keyword abstract over here. So basically what we're trying to do here is we're going to create an abstract class on the name of person, and this particular person will be having the name and gender. So once the abstract class is created, we are going to instantiate this particular blueprint or the main class to create an object which is an employee. So basically our object here will be Mr. Pawan. So Mr. Pawan Jain, who is going to be the object out of the class person. Right? So this is the blueprint, the person is the blueprint, and we are using this particular person blueprint to create this employee object, which is Mr. Pawan Jain, who happens to be an employee for a certain company. Now we will run this code and see the output. Don't worry, you will be having the access to the code and you can apply your own modifications and you can execute this program in your own system and have a deep understanding of the code. So now let's run this code. So there you go, we have successfully instantiated the person class, which is the main abstract class, and we have created our object that happens to be Mr. Pawan Jain and his gender is male. So this is how basically the classes and object work, and this is how the abstract classes work. We are hiding the implementation here, we are just providing the necessary information what the user needs. The necessary information is if the object has successfully created or not, or if the employee Mr. Pawan Jain has logged into the company or not. So that's what exactly is the technicality of abstract classes. Now with this, let's continue with the next concept in the object-oriented programming in Java. So the next concept in the object-oriented programming in Java will be about the different ways to achieve abstraction. So we have already dealt with one method of obtaining abstraction, which is by using the abstract classes, and we also have another way of implementing abstraction without using abstract class. So that particular way is by using interface. And this particular interface is also used in another way. It will also come handy when you wanted to implement inheritance by multiple classes. So we will discuss about that, the multiple inheritance trouble and diamond problem and types of inheritances in a bit more detail in the upcoming concepts. For now, let's understand what exactly is an interface, and let's also check out a basic example for interface. So now the definition of interface. An interface is actually a container that stores the signatures of methods to be implemented in the code segment. So basically, if you look into the previous example, in the employee class, we have declared the complete method. That means we have completely written the implementation details, the logics used in the method. But when it comes to interface, we just write the method signature. So complete method is different from complete method signature. So method signature will be the name of the method, but inside that particular method, no particular code segment will be written, but the implementation part will be written separately apart or outside the interface. Now for a better understanding, yeah, I know this is a little bit confusing. Now we will understand this through an example. I think that will be a bit clear to you. Let's switch to the Eclipse mode again. So now we are in the Eclipse mode again. So let me give you a brief overview of how to create an interface. So basically you navigate to the package. So here we have the Simplilearn Java package. Right click on it and you can see a dialog box, and inside that you can see new option, and you can see another dialog box or drop down menu, and there you can see an option called interface. So when you click this, you will have a new dialog box. Then you can just provide some name to your interface. Now let me just provide Simplilearn and just finish. And there you go, you have the interface created. Now right now we don't need this interface specifically. We have already designed an interface for us. So the interface for this particular program is area.java. So you can see that inside area.java we have method signatures. Remember the method signatures that we spoke about in the definition? So this is what I meant about the method signature. So we have the public void square. So this particular interface is designed to calculate the area of different shapes. So first we have the square, next we have the circle, the rectangle, and the triangle. But wait a minute, we don't have the formula. For square we have the formula side into side, but where is the implementation of this particular area calculation? And similarly we have circle pi r square, so where is the implementation? And similarly for rectangle we don't have the implementation, and triangle we don't have the implementation. We just have the method signature. So where exactly is the method implementation? Yes, so here we are avoiding the user from the complex implementation of the code. So the complex implementation of this particular code is inside shape area class. So you can see for the first one, which is the circle, we have the code implementation over here. So we will take the input of the radius from user. So we have the scanner class over here which will read the input, and similarly we have the implementation for square. So we will take the input again, which is kb2 keyboard 2, and again we have the implementation for rectangle kb3, which is the keyboard 3. Then at last we have the triangle, we have kb4, which takes the input for the height of the triangle and base of the triangle, and then we have the calculation over here which says height into base into 0.5. Basically the formula is half into base into height. So half is 1/2, so the value of 1/2 will be 0.5. So that's how it goes on, and here we will call the methods. So that's how the interface works. Now let's quickly run the program and see the output. Wait a minute, there is some error. So on this note I would like to give you a quote, maybe. Yeah, when it doesn't work for the first time, call it version 1. So don't worry when you face errors. Okay, we have specific groups for Java programming in Telegram. You can post your errors, or if you have any issues in your projects or any type of problems related to programming, you can directly copy paste your error into that group and we will answer your questions, because we are a group of professional Java programmers and we are also a group of edtech organizations. So we have a good knowledge of Java and we really believe that we can help you out. So for now, let's try to refresh the package. And let's check one last time if we have any kind of issues or warnings or errors on the program. So far I can't see anything. So let's try to give it a one last try. Now we have gone through the one final checklist through the entire code and we found no errors or no warnings. So even in the interface. Now let's try to run it again. So there you go. It's running successfully. So once you get some kind of errors or warnings, don't worry. Just try to refresh the code and try to fetch some warnings or any issues regarding code and try to fix them. And yeah, that should help. Now coming back to our console, you can see that the console is asking for an input for radius. Now let's provide the input, 15, and there you go. We have our output over here which says 706 units as the area of the circle. Now in the next section, the console is asking for us for an input for the square, length of the square. So let's provide 10. So the formula is s into s, so it must give us 100. Now the console has continued into the rectangle. Now let's provide the length part of the rectangle and now the breadth. So the area is 252 and now it's asking for the base of the rectangle, then now the height of the rectangle, and now the area is 625. So this is how the interface works. So basically the implementation has been hidden from the end user and we just have the method signatures over here. So that's how it works. Now let's continue with the next topic in our Java programming. So the next topic is the encapsulation. So in the object programming concepts in Java, the process of encapsulation is bundling the data and methods that operate on the data. A little bit confusing, I understand, but let me clarify this. So basically, in object-oriented programming, you will be having objects, classes, and inside the classes, you will be having data members. So data members are nothing but the variables which are storing your values. So for example, int a is equals to 10, int b is equals to 20. So a and b are your data members. And data manipulating methods, or simply called as methods. For example, if you wanted to perform an addition operation on a and b, so you will be writing some method call, and inside the method call you'll be declaring some parameters which are int a, int b. So that particular method which will perform the addition operation inside the sum method, you will be having a plus b. So that's exactly what I mean, the data manipulation methods. So the data members a and b and the data manipulating method which is sum a plus b. So these two are encapsulated together or kept together by using the process of encapsulation. So the term is encapsulating the data members and methods. So still it might be a little confusing, but let me clarify you about that in a bit more detail by the practical session. Now let's switch back to Eclipse again, where we will understand encapsulation in Java in a bit more detail and in a little more depth. So on my screen you can see two different programs. So the first one is the encapsulate class and the second one is the run class. So basically what we are doing in the run class. So in the run class, just imagine that we have some person, his age and the ID number. Let's consider that Harry is 25 years old and he works for a company, or maybe he is into some college, so we have some ID number generated for Harry. So what we are going to do is we are just going to create a profile of Harry. So we'll be setting the name, setting the age and setting the ID. So this is simple. Now let's get back into the encapsulation class. So here you can see that we have some private variables, name, ID and int age. So what we're going to do here is we are going to get the age of Harry, and we are going to get the name of Harry. We are going to get the ID of Harry. So basically these are the get and set methods. So after getting those name, age and ID values, we are going to set the age, name and values of Harry. So what we are doing here is we are encapsulating the methods and data members together in one single class. Now I hope this overview gave you a little bit idea of how encapsulation basically works. Now let's quickly run this program and see the output. Yep, again it throws some kind of error. Don't worry. Let's try to refresh the package once again. Now let's try to run the package as a Java application. I hope this should help. Yeah, don't worry, sometimes these kind of minor issues are thrown, so you just have to refresh your package or do an error check or warning check on your code, and that should really help. No worries on that. So we have got the program executed, and we have also got our output which says name is Harry, age is 25 and the ID is 800 and not 800, it's 8,25,000. It's let me just increase the font size. So it's 8,29,468. Yeah, or 829468. Cool. Now let's continue with the next concept in our Java programming. Now the next concept happens to be a really important one, which is the inheritance. So what is inheritance? Inheritance is an act through which a new class gets created by acquiring the variables and methods defined in the parent class. So a lot of parent and child relationship over here. So what exactly happens is just imagine that you wanted to create a new phone. So what's the basic functionality of a mobile phone? So you send text messages and you try to call someone, right? So this happens to be some second generation phones such as the 1100 Nokia series. So these are an older generation of phones. Now you wanted to create a new, brand new, the latest generation phone, which are the smartphones. So in a smartphone, you will be having some extra functionalities such as taking pictures, or if you wanted to record a video, or if you wanted to use social media, internet browsing. So these kind of extra features. So these extra features were not available in 1100. But there is one similarity between 1100 and your latest smartphone. That is creating an SMS and sending it and making a call. So making a call and writing an SMS itself is a complex coding pattern. So when you try to create your smartphone, will you try to write the entire code section once again, or will you try to copy paste that code into your new phone? So copy pasting will be efficient, right? So the time saving. So you can consider the same kind of technicality in inheritance. So when you already have a data member declared and when you already have a data manipulating method defined, you can inherit or you can borrow that particular method from a different class to your new class. So the class which is going to borrow the method from another class is called as the child class, and the method which provides or which donates the data members and the data manipulating methods to a different class is called as the parent class. Yeah, so this should have given you an overview. So now let's understand in a bit more detail and in-depth kind of approach to inheritance in practical sessions. But before that, we have some different varieties of inheritance in Java. Now let's dive into the types of varieties in inheritance in Java. So there are basically 4 varieties, which are the single inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So consider taking a screenshot of this so that you can have a quick overview. So the first level A classes, which are colored in blue color, are the parent classes, and the next level classes are the child classes. So in the first type of inheritance, we can find A is providing the data members or data manipulation methods to the class B. So here class B is a child class and A is the parent class. Similarly, in multi-level inheritance, so this is similar to the single level inheritance, but the difference is C is inheriting some properties from B as well as the properties from A. So this happens to be multi-leveled kind of inheritance. And on the third kind, we can see there are multiple classes inheriting the properties from one single parent. So you can see that A is providing the data members and data manipulating methods to all the three child classes, which are B, C, and D. And finally, we have the hybrid inheritance. So the name itself is self-explanatory. So the term hybrid refers to the combination of all the other three kind of inheritances. So you can see at the first level, there is hierarchical inheritance. So B and C are inheriting the same property from A. And in the next level, we can see that there is single inheritance between parent class C and child class D. And if you consider the relationship between parent class A, child class C, and child class D, then you can see that there is multi-level inheritance. So this particular inheritance is a combination of all the three inheritances. So apart from these four, there is another type of inheritance. So that particular inheritance is called the multiple inheritance. But in Java, when you try to implement multiple inheritance, there is a serious chance of ambiguity. So for that one reason, Java authors decided not to include multiple inheritance. So if you wanted to implement multiple inheritance, for that purpose, you can make use of interface. So interface gives you the logical approach of multiple inheritance, but without the ambiguity of diamond problem. Now let's try to understand all these types of inheritances in a much more detailed and elaborate way through the practical session. Now let's get back to the Eclipse screen again. Now we are back on the Eclipse mode right now. So on my screen you can see a simple program which says single. So the name of the program is single, or the main class is single. So we have two particular classes. So the student class is the parent class and the Bob class is the child class. So what you're going to do here is you're going to extend the properties of student class into the Bob class. That basically means you're trying to borrow some methods or data members from the parent class into the child class. Now let's try to execute this program and see the output. So there you go. The properties of parent class, which was basically a small printf statement, are being extended by the child class, and both these messages are being successfully printed in the output console. Now let's try to execute another program based on inheritance, but this time we will execute the program based on multi-level inheritance. So on my screen you can see another example based on inheritance, but this time we are going to implement multi-level inheritance. So basically we have the parent class that happens to be the bike class, and inside the bike class we have two printf messages, and now followed by the main parent class we have the first child class, that is the Ninja. So Ninja is a bike from the brand Kawasaki, and now Ninja is going to extend the first parent class, that is the bike, so that it will inherit the properties of a bike. Now followed by that we have another class, or you can say child class, which is Ninja 1000R. So inside the Ninja segment we have different varieties. So the variety what we are dealing here is the Ninja 1000R. So this particular Ninja 1000R is going to extend the Ninja segment or the Ninja class, and it is going to borrow the properties of a Ninja segment bike, and above that Ninja bike is going to extend the properties of a two-wheeler. Now this is the flow what I have designed for this particular program so that it looks a little simple to understand. Now let's try to run this program and see the output. So there you go. We have the program successfully executed and we have the output on the console. So make is the Ninja. Ninja model is the 1000R. Bike type is a sports type. Manufacturer is Kawasaki and the maximum speed is 280 km per hour. Now let's move into the next type of inheritance, that is the hierarchical inheritance. So on my screen you can see another example based on inheritance, but this time you're going to deal with hierarchical inheritance. So as discussed before in the theory part, hierarchical inheritance has multiple child classes which are going to inherit the properties of one single parent. So here, that one single parent happens to be the employee class. And followed by that, we have two different varieties of child classes which are p-employee. So p-employee is basically the permanent employee, and the t-employee is basically the temporary employee. So both the temporary and permanent employees are going to extend the properties of employee. So inside the employee, we have one data member, which is the leaves. So both for a permanent employee and the temporary employee, the company provides the same number of leaves, that is 25. But they have different working hours though. Just to make sure that these two classes also have some data members, I have included the total work hours per day for both permanent employee and temporary employee. Now let's try to execute this program and see the output if these two child classes are capable to inherit the properties which are the leaves from the main class or the parent class. So there you go. The program got successfully executed and the output got generated on the output console. You can see that the total number of leaves for both permanent employee and temporary employee are same, that is 25. That means both the permanent employee and temporary employee have inherited the properties from the parent class or one single parent class, that is the employee. So that's how the hierarchical inheritance works. Now let's move ahead into the last type of inheritance, that is the hybrid inheritance. So you can see that we have an example on my screen which is based on hybrid inheritance. So in hybrid inheritance, different childs are going to inherit from different parents in a different manner. So to make things a bit more comfortable, I have designed this particular program based on the theoretical part what we have discussed. So when we get back into the theory part, we can see that in the hybrid inheritance, two child classes which are B and C are inheriting the hierarchical inheritance from the class A, and the class C and class D are in the form of a single inheritance, and D is extending from C. And here you can see that D is also extending C as well as A, which forms as a multi-level inheritance. Now we shall try to execute a program on the same type of inheritance or the same type of approach. So to understand this program, we need to execute this program so that the output print statements can explain us in a better way. Now let's quickly try to execute this program and see the output. So you can see that the program got successfully executed and we have the specific messages over here. So the first one has to say that C has single inheritance with class A and shares hierarchy with B. Let's verify it. So C has a single inheritance with A and shares hierarchy with B. So that's true. And followed by that, A is the parent of all the classes, including B, C, and D. Yeah, that's true. And B has single inheritance with A and shares hierarchy with C. And also that is true. B has single inheritance with A and shares hierarchy with C. And lastly, D has single inheritance with C and multi-level inheritance with A. So let's check that out. Yeah, D has single inheritance with C and a multi-level inheritance with A. So I hope you understood how the hybrid inheritance works. Now with this, let's move into the next concept in object-oriented programming, that is the polymorphism in Java. So we will begin by understanding the definition of polymorphism. So basically, polymorphism is the ability of any object in a class to perform tasks in multiple methods. So this type of approach is called as polymorphism in Java. So there are two types of polymorphism: runtime polymorphism and compile time polymorphism. So to understand things in a much better way, we shall move through a practical session. Let's consider a method. Okay, let's consider some addition method. So in your program, you wanted to perform addition on two different operators, and there might be a situation that you wanted to perform the same addition operation on three different operators. But the suspense here is you wanted to specify the name of the method with add, and for both the methods you'll be having the same name. right? So this might create an ambiguity, but you can avoid this by specifying the number of parameters. When you pass the method, or when you create a method call with 2 parameters, then the first method will be called. When you pass 3 parameters, then the second method will be called, which has 3 operators. So basically the evaluation of this particular command will take place during the runtime, and sometimes similar kind of operations takes place during the compile time. So this is what polymorphism is. So to understand what polymorphism exactly is, and what is a runtime polymorphism and what is a compile time polymorphism, we shall quickly dive into the practical mode so that we can have an in-depth understanding. Now let's first get back to Eclipse and try to execute some programs based on polymorphism, runtime polymorphism, and compile time polymorphism. So on my screen you can see the program based on polymorphism. So basically we have 4 different classes. The first one will be the animal sounds class. Next we have the cow class, which will be extending the same animal sounds parent class. Next we have cat, and followed by that we have the dog. So basically what we're going to do here is we're going to call the sound method, and the sound method belonging to that particular class will be executed based on the parameter or based on the object that got created. Now let's try to execute this program and see the output. So there you go, the program got successfully executed and the sound method is successfully implemented based on the method call. So you can see that we have called the cow sound method twice and it got mo mo over here. So that's what the cow makes as a sound, and dog says bow wow, something similar like that. So basically the method calls are resolved during the runtime based on the object created and the method called. So basically in polymorphism we also have method overriding and method overloading. We will understand the concepts through an example. So as discussed before, we have the same addition operation example over here. So here we have different types of methods. They might look the same because the name of the method is add basically, but if you look at the parameters a little bit closely, you can see that the first method has 2 parameters and both the parameters are of integer data type. And similarly, when you look at to the third add method, it also has 2 parameters, but the data type is double. So when you pass a double kind of data type, then the third method will be used. If you provide the integer data types, then the first method will be used to perform the addition operation. But if you provide 4 parameters, all of double type, then the second method will be used. So this type of method resolution in runtime is called as method overloading. Now let's try to execute this program and see the output. So there you go, the program got successfully executed, and as you can see in the main program, we have already forwarded the parameters through the function call and the data got executed and we have the output over here. Now let's go into method overriding and understand the concept through a practical program. So on my screen you can see another example based on polymorphism, but this particular program deals with method overriding. So you can see the cargo pilot and the civilian pilot. So basically they both want to fly a plane. So to fly a plane they need to take off from the runway. So the fly plane method will be resolved in runtime. So whichever the object is called or whichever the object calls the method, then that particular method will be executed for that particular object. Now here we are going to comment out the civilian pilot and we are going to open the cargo pilot. So when we run this program, the cargo pilot object could be able to execute the fly plane method. Now let's try to execute this program and see the output. So there you go, the program got successfully executed and the cargo pilot was free to take off, and he just gave us the message which says this is cargo pilot ready to take off. Similarly, when we comment out the cargo pilot and try to open the civilian pilot, then things get a little changed. So this time the civilian pilot will be executed. So here the fly plane method got overridden by the civilian pilot. So this is how the method overriding works in real time. Now with this, let's move ahead into the next concept in Java's programming tutorial. So the next concept in Java's programming tutorial is the Java collections. So Java collections are basically the data structures used in Java. So we have the Java collections from the iterable library class in the Java's library, and followed by that we have the collections. Then inside the collection we have three different varieties, which are the list, queue, and set. So when we dig deep into list, queue, and sets, we have the array list, linked list, vector, stack, and similarly on the queue we have priority queue, dequeue, array queue, and when we get into set we have hash set, linked hash set, and sorted set, tree set, and much more. So Java's collections is a whole new level concept. So to understand Java's collections in a much more detailed way, along with some practical programs, I will drop down the link in the description box below, which will redirect you to Simplilearn's Java collections tutorial, which has the explanation to all the Java collections or Java data structures in a much more detailed way, along with the practical examples. Now to continue with the next topic, we have the enumeration. So what do you mean by enumeration in Java? So enumeration is a class type and it can have constructors, methods, and instance variables. So it is created by using the enum keyword. Now to understand enumeration in a much better way, we shall go through a practical example. So basically enum can be considered as a general data structure like array, which is designed to store some elements. I think you can have a better understanding when you actually look at the program. So let's switch back to the Eclipse mode. So there you go, you can see an example of enum on my screen right now. So enum is basically a data structure that stores the elements. So here we are storing the elements Honda, Hyundai, and Suzuki, which are the brands of car makers. So what's the difference between an array or any other data structure and enum is? So if you provide some elements into a data structure like array, they can be varied through some data manipulating operations. So when you declare the same elements using an enum, it's impossible to change the elements in an enum. Now we are going to access the name of some brands through this particular statement here. Now let's try to execute this program and see the output. So there you go, the program got successfully executed and one of the elements from the enum collection has been printed on the console. Now with this, let's continue with the next concept in the Java's programming tutorial, that is the exception handling. So what is an exception? What is an error? So exception is basically an unexpected scenario that pops up during the runtime and disrupts the normal executional flow of a program. Now what is an error? So an error is an unexpected event that arises due to logical or syntactical mistakes and is capable to bring down the complete program. So an exception is something which is not powerful enough to completely crash your code, but it is capable to stop or disrupt its normal flow. Just for example, consider that you wanted to apply some division operation. So you will be providing some positive integers or negative integers or any kind of float or double values during the operation. But consider that you have one normal number, which is an integer number, and the other one is 0. Is it possible to divide any number through 0? No, right? So this kind of input will disrupt the normal flow or sometimes even crash the program. So this kind of problems are called as exceptions. And similarly, on the other hand, when we get into errors is a completely new scenario. So error will be arised when you provide some wrong logic in your code. For example, you wanted to perform division operation. So instead of / you gave some other symbol like pipe symbol or anything. So the computer might not understand what's the meaning of that particular symbol. So this is where some logical or syntactical mistake arises and that ends up as an error. So to understand errors and exceptions in a much more better way, I will drop down the link in the description box below, which will redirect you to Simplilearn's exception handling tutorial with some detailed explanation of exceptions and errors and how to handle them in real time. And also they have some very nice examples for exceptions and how to resolve them in real time. Now followed by this, we will advance into our next topic, which will be about file operations. So file handling can be defined as a procedure to manipulate data via file system. So it includes to create, get, read and write operations. So basically what will you be doing is you'll be creating a file, get some information if it has, or if you wanted to write some information into it, if you want, then you can do it. And after writing, you can even read the information which is present in that file. Now let's try to create a new file in my file system and try to write some data into it and then try to read it. Now let's switch back to Eclipse again. So now you can see that on my screen we have another example based on file operation techniques. So this time we are going to perform the write operation. So what we are basically going to do is we are going to write the text message status. Files in Java might be tricky, but it is fun enough. Now we are going to write the same data in Simplilearn doc.txt. So for that, let's quickly run the program and see the output. Now let's get back to my file system and see if the data is written in the document. Now let's open the Simplilearn doc text document. So as you can see, the files in Java might be tricky, but it's fun enough. So this is the exactly same message what we wanted to write. So files in Java might be tricky, but it's fun enough. Now the last type of file manipulating operations will be the read operations. Now we will try to read the text which is present in Simplilearn doc.txt. So now on my screen you can see an operation for reading the text data present in Simplilearn doc.txt. Now let's quickly run this program and see if it can read the data present in that particular text document or not. So there you go, the program got successfully executed and the command read the data which is present in Simplilearn doc.txt. So the text data what we wrote in that particular file was files in Java might be tricky, but it is fun enough. So with this we have come to an end of this particular Java programming tutorial. I hope you enjoyed this. If you have any queries regarding this tutorial, or if you are in need of the text document which has all the codes and programs that we executed in this particular tutorial, then please feel free to write us down in the comment section below and we will respond to you at the earliest. This is Ravi signing off. Until next time, thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.